This video will introduce the concept of computational problems and how they are different from real-world problems. Computational problems are the class of all mathematical problems that can be solved using just a computer. For example, sorting an array of integers is a very typical problem that you would be able to make a computer do. While solving global warming is a much more complicated issue that requires scientists, policymakers, and computers all coming together to form a solution. Ultimately, the goal of any course on data structures and algorithms is to provide you with the tools necessary to solve computational problems. But before we pick up these tools, we must first be able to recognize whether or not a problem is framed clearly enough to be fed into a computer. In order to understand this, let's look at some more subtle examples. Pause the video and take a moment to think about whether or not these two problems qualify as computational problems. So let's look at the first problem now. At 182 centimeters, both Bob and Carol qualify as the tallest person, but a computer cannot decide between Bob and Carol because there is no tie-breaking criterion, and a computer is a deterministic machine that cannot make choices without a predefined rule. Hence, we can safely conclude that due to an unresolved ambiguity, this problem is not a computational problem. The second problem is also not a computational problem, but due to a very different reason. Here, it's not clear where we are pulling this rating from, because it's not as if there's a universal database of movie ratings. In fact, there are so many websites from which you can extract movie ratings, like IMDb, Rotten Tomatoes, and a computer cannot choose one among these websites by itself. I hope all that gave you a feel for how ambiguous, subjective, and poorly defined real-world problems are, and how hard it is to convert real-world problems into computational problems. You have to remove ambiguities, formalize the problem if it's written a little informally, and quantify all parameters of the problem. But once our computational problem is properly framed, the next step is to find an algorithm that can solve it. And once that has also been made, the last step is to implement the algorithm in code in the form of a program. We'll learn more about algorithms and programs in the upcoming videos, but as a whole, these four steps comprise the software engineering pipeline that solves a real-world problem using software. Okay, so that brings us to the end of this video. So what do you take home from this lecture? At least with regards to coding interviews, you should be fluent with performing all three of these arrows. For example, you could be given an intentionally vague problem and be expected to distill it into a computational problem by adding tiebreakers and quantifying all aspects of the problem. And of course, you should be fluent in writing algorithms as well as programs.